Okay, let's go for it. Can you advance the slide, Arun? So welcome today to Arun Kumar's seminar, role of phytase enzyme in monogastric nutrition. Next slide, please, Arun. My name's Craig Hardner. I'm a Principal Research Fellow at the Centre for Horticultural Science. I'm also the chair of the QAAFI Science Seminar Committee and try and build the diversity of the presentations we've seen throughout the year. Next one, please, Arun. I'd like to start by acknowledging the traditional owners and their custodianship in the lands on which we meet. I pay my deep respects on our behalf to their ancestors and their descendants who continue cultural and spiritual connections to country. We recognise their very valuable contributions to Australian and global society that makes us a unique country. Next one, Arun. So just reminding you on the housekeeping rules. So today's seminar is scheduled to between 12 and 1. So we'll be wrapping up about 1 o'clock. And after Arun will speak for about 40 odd minutes, he tells me. So after that, we'll have a question answer session. To participate in the question answer session, can you use the question answer tab on the on Zoom? Don't use the chat because we don't use the chat function, so it will disappear into thin air. But I do encourage you to participate in the question answer after that to explore the different dimensions of Arun's work. Can we next slide, please? And now I'd just like to introduce Arun. So Arun, Dr. Kumar is a highly experienced researcher who's been associated with the School of Ag and Food Science at the University of Queensland for over 28 years. And during a tenure, he's conducted over 140 experiments on nutrition digestibility and production performance in broilers, layers, turkeys, pigs, and sows, primarily for multinational companies. His work is focused on developing products to enhance pig and poultry production and welfare. In 2022, Dr. Kumar joined Eugeni Roura's group at QAAFI as a senior research officer. He's currently part of a large AgriFuture consortium headed by Eugeni. And I welcome Arun to this and interested to hear what you've got to say, Arun. So over to you.
Okay, thank you very much for a nice introduction, Craig. I will start my presentation acknowledging traditional owners and their custodianship of the lands on which we meet today and pay my respects to their ancestors and their descendants. Okay, what I'm going to present today here, it's based on studies conducted at University of Queensland at Gatton campus on pigs and poultry. This is my presentation outline. So I'll start with the introduction for phytase, phytate, and mode of action of phytase, importance of phosphorus in pigs and poultry, sources of phosphorus for monogastric animals, phosphorus pollution, and the effect of phytase supplementation as a phosphorus sources in broilers, layers, turkeys, pigs, and sows. Okay, before getting into the details, let's familiar with phytase and phytate. So what is phytase? Why we need to use? What is the advantages of using phytase as a source of phosphorus in case of pigs and poultry rather than using traditional sources such as inorganic phosphates or meat and bone meal? So phytase enzyme, phytase is an enzyme. It hydrolyzes phytate phosphorus and releases phosphorus from phytic acid. It not only hydrolyzes phytate phosphorus, it also hydrolyzes the calcium, phosphorus, phytate bound calcium, magnesium, iron, amino acids, and energy. So what is phytate and why phytase enzyme is important in monogastric diets? Let's see. The phytate is a storage form of phosphorus in plants. So it poses certain anti-nutritional factors in monogastric diets by reducing digestibility and availability of minerals, amino acids, and energy. Let's see the mode of action of phytase. Yeah, these are the cereal grains, pulses, and vegetable proteins we normally use in both pig and poultry diets. The phosphorus present in these ingredients is in the form of phytate phosphorus, because here the free phosphorus combines with phytic acid and it forms into a phytate phosphorus. This phytate phosphorus is not able to phytate phosphorus is not able to utilize by pigs and poultry, because these pigs and poultry, they don't produce phytase enzymes to break the bonds between phosphorus and acid groups here. So that's why what we do in monogastric diets, that's both in pigs and poultry, we supplement a commercial phytase, or what we call feed phytase. When you supplement feed phytase, this feed phytase will break down the bonds here in the phytate phosphorus and makes the phosphorus available to use by pigs and poultry. So why the phosphorus is important? So probably we all know that it's extremely important for formation of bones, formation of sugars and sugar phosphates such as ADPs and ATPs, and phosphoproteins, phospholipids, nucleic acids, and extremely important for production of meat and eggs. So what's the requirement of phosphorus? Requirement of phosphorus varies between different animals. So in case of broilers, it's anywhere between 8.8 to 0.68, layers 0.7 to 0.8, turkeys around 1 to 0.5, pigs 0.7 to 0.6, and in sows 0.8 to 0.7. The requirement of phosphorus even varies when at the different age groups. So when the animals are younger, the requirement is higher than when the animals are old. So what happens if you don't provide enough phosphorus in the feed? So the phosphorus deficiency causes poor growth performance, leg problems, and also causes a lot of diseases due to lack of immunity. So how are we going to supplement? How are we going to meet the requirements of this phosphorus for pigs and poultry? So we got 3 different sources. By using these 3 different sources, we can meet their requirement. The number 1 is the inorganic phosphates in the form of dicalcium phosphate or monocalcium phosphate. And also we can use bone and meat meal as a source of phosphorus. And the last one is phytase enzyme. Let's see one by one what are the advantages and disadvantages. Okay, let's see the inorganic phosphates in the form of dicalcium phosphate and monocalcium phosphate. So dicalcium and monocalcium phosphate has got a high level of phosphorus. So approximately it's got about around 20% of phosphorus and 24% of calcium. So that can be used as a source of phosphorus in monogastric diets. But there is a limitation here. The limitation here, that's why the use of dicalcium phosphate and monocalcium phosphate has been banned in several European countries. Let's see why these phosphorus supplements has been banned in European countries. The reason, one of the main reason is, so when you include these dicalcium and monocalcium phosphate, the undigested phosphorus from these sources and unutilized and undigested phosphorus sources get excreted out of the animal in the form of excreta, and that excreta from pigs and poultry will be used, converted into manure. That manure will be used for crop production. So when we use this manure for a crop production, then what happens? This undigested phytate phosphorus reacts with soil microorganisms and it releases more phosphorus in addition to whatever the inorganic phosphorus added for crop growing. Then the phosphorus level goes significantly higher in soil. That excess phosphorus leaches or runs off into water streams, ponds, and rivers, causes eutrophication. With the eutrophication, you can see there is a full of algal growth on top layer of the water. That it's not only algal growth, you can see a lot of weeds growing here because there is a lot of phosphorus and other nutrients present in this water. Let's see the sequence, how the phosphorus pollution takes place in rivers and streams. You can see this crop, this is agriculture, growing crops. For growing crops, people use a lot of NPK, that's inorganic fertilizer, and also people use chicken and pig manure for growing crops. When you use chicken and pig manure, as I said earlier, the undigested phytate phosphorus combines with the soil microorganisms, then it releases more phosphorus. That excess released phosphorus will run off into the rivers and streams here. It's not only that, you can see there is a phosphorus leach underground and it reaches this water and that causes the eutrophication. That's green spot where what you see, it's exactly like that. When the whole water, the top layer of the water covered with either weeds or with algae, then you can see this is the sunlight. Sunlight will not be able to reach the weeds or algae present in here. Then this will die and forms a debris, and these debris will be eaten by bacteria, and those bacteria utilize most of the water present inside the water, most of the dissolved oxygen. Then what happens in water, it drops oxygen levels. That's going to be very detrimental for aquatic animals, including fish here. So you can see a lot of fish here. That's very bad for aquatic animals. That's the reason why dicalcium phosphate and monocalcium phosphate has been banned in several countries in Europe. So what's our second? Okay, so this one here you can see how phosphorus pollution of water reservoirs, the most important contributor for phosphorus pollution is growing crops. 43% of the phosphorus pollution in water reservoirs comes from crop growth or agriculture, and another 37% from livestock farming, and rest of the 20% comes from natural sources and urban population related sources. Okay, the other source is meat and bone meal. Meat and bone meal is an extremely good source of calcium and phosphorus and also protein. So meat and bone meal has got up to 5% of phosphorus, 10% of calcium, and up to just over 50% of a good quality protein. In spite of such a good nutritional value in meat and bone meals, again, this has been banned in some of the European countries because if you feed this meat and bone meal for animals, that poses a lot of diseases. That's the reason, again, the use of meat and bone meal is banned in certain countries. So the only alternative left now is use of phytate as a source of phosphorus for pigs and poultry. As I explained earlier, when this form of phytate will not be able to utilize by pigs and poultry. That's why we add feed enzymes. When you add feed enzymes, these enzymes goes and they break these phytate bonds and releases free phosphorus. Thus, phosphorus can be utilized by pigs and poultry. So all these feed phytases are commercially produced using different strains of bacteria and fungi. Okay, let's see the efficacy of these phytase enzymes as a source of phosphorus in pigs and poultry diets on production and nutrient digestibilities. I've done, or as Craig said, I've done over 140 different studies, not only on phytase enzyme, including carbohydrate enzyme and phytase and protease enzymes. but I'm not going to present all of them today. Yeah. So what I did actually, I selected only five studies which are very, very simple and straightforward and easy to understand for each and every person. So before going to the details of my studies, let's see the type of diets I've used in my studies and the Phytase dose included in those diets. Had a positive control diets. The positive control diets refers to standard diets with no reduction in nutrients. These diets are formulated as per breeder recommendations. So whereas in case of negative control diets were formulated with reduced nutrients. In most cases, phosphorus reduction by 40%, calcium reduction up to 20%, and gross energy anywhere between 70 to up to 100 calories per kg of feed. And then we add Phytase at 0 to 5,500, 1,000 or 2,000 units per kg of feed. By formulating these negative control diets, by reducing nutrients, you can save quite a bit of money. So usually the diets formulated with reduction in nutrient levels are almost about 20 to 25% cheaper than the positive control diets. So, okay, my first experiment is on broilers. So in this study, we had three different diets. One is a negative control diet that's reduced in phosphorus and calcium, and the same diets were supplemented either with 500 Phytase units per kg of feed or 1,000 Phytase units per kg of feed, and major ingredients were corn, soybean meal. And each diet had 10 replications per diet, 15 birds per replication. There were about 450 birds, and duration was 21 days. So, okay, what are the parameters we measured here? We measured weight gain and feed conversion ratio at day 21. So you could see the weight gain here in negative control diets compared to enzyme supplemented groups. Here, negative control diets, the weight gain was significantly lower than the enzyme supplemented groups, where we supplemented 500 Phytase units. So when the same diets were supplemented with 1,000 units, did not show any significant benefit in weight gain. When you come to feed conversion ratio, so feed conversion ratio is amount of feed or grams of feed required to gain a gram of weight. So in negative control diets where the nutrients are reduced, they had to eat almost 2.5 grams of feed to gain 1 gram of body weight. Whereas in case of enzyme supplemented group E at 500 FTU, they had to eat only 2 grams per kg of feed, per kg of gain. Whereas when you supplemented 1,000 Phytase units, you can see they had to eat much lesser feed to gain 1 gram of feed. The reason why this feed efficiency is better when you supplemented these diets, Phytase supplementation diets, you can see here, because this helps to improve gross energy digestibility and protein digestibility. You can see the digestibility of gross energy here is only 65%. Whereas in case of Phytase supplemented groups, gross energy digestibility was significantly improved by 10% here. But here there is no difference between these two groups. So we don't need to supplement 1,000 FTU, just we can stop supplementing here. Similarly, in case of protein digestibility, if you look at the protein digestibility, again, negative control diets, so the protein digestibility was significantly lower than the diet supplemented with Phytase enzyme. So this is the reason why feed conversion ratio was significantly better in enzyme supplemented groups than unsupplemented groups. And when you look at the Phytate phosphorus digestibility and total phosphorus digestibility, again, you can see in negative control diets, digestibility of Phytate phosphorus is significantly lower than digestibility in enzyme supplemented groups. Here, there is an advantage in case of phytate phosphorus digestibility when you include or when you increase dose from 500 to 1000 phytase units. It's similar to this one in case of ER. In total phosphorus digestibility, the negative control diets at only 51. By supplementing only 500 FTUs did not significantly influence phytase, total phosphorus digestibility. However, when you supplement 1000 FTU, you can see a significant improvement in total phosphorus digestibility. So next one is in layers. In layers, we had, in this study, we had 3 different diets. One is a positive control diet. In positive control diet, we did not reduce any nutrients. All the nutrients, the diets were formulated as per the breeder's recommendation. And in case of negative control diets, we reduced dietary proteins and we reduced dietary phosphorus and calcium, and same diets were supplemented with 300 phytase units. And the ingredients we used for formulating diets were corn, wheat, and soybean-based diet. And in year, each diet had 12 replications per diet, 4 birds per replication, and total number of birds were 144, and total duration, sorry, it's not 26 days, it is 26 weeks, that's 6 months. Okay, what we did, what we measured here, egg production. You could see here, there are 2 types of egg production measurements here. One is hen-housed egg production, and one is hen-day egg production. So what is the difference between hen-housed egg production and hen-day egg production? When you calculate hen-housed egg production, we don't take mortality into consideration. Whereas in case of calculating hen-day egg production, we do take mortality into consideration. Okay, in both cases, you can see in negative control groups where the nutrients are formulated to low levels, so they laid less eggs compared to positive control group where they had, these group had the standard nutrients. However, when you supplement these negative control groups with the 300 phytase units, you can see a big jump here in egg production. It was significantly different. It's the same thing happened when you calculate hen-day egg production. Here also, when you supplement phytase enzyme at 300 FTU, you could see a significant increase in egg production. Next one is the egg weight and egg mass production. So what's the difference between egg weight and egg mass? Egg weight is the average weight of an egg. So egg mass is the total weight of the total mass of the eggs. That means total number of eggs produced, average weight multiplied by, you'll get a value, you divide that value by number of eggs, number of birds and total number of experimental days. That gives the gram egg per bird per day. Okay, let's see what happened here. The egg weight, the birds ate negative control diets with the low calcium and phosphorus laid as smaller eggs compared to the positive control group where they have laid significantly bigger eggs. But when you supplement these negative control groups with the 300 phytase units, you can see a big jump in egg weight. So then they start laying bigger eggs. Similar to that, in case of egg mass also, the negative control diet supplemented with phytase enzyme, you can see a big jump in total egg mass. If you look at the feed intake, the negative control groups, they ate less feed compared to positive control groups and also compared to enzyme supplemented groups. But however, the difference in feed intake was not statistically significant. When you look at the feed conversion ratio, that's in eggs, the feed conversion ratio is calculated based on grams of feed required to produce a gram egg. Here in a positive control group, so birds had to eat almost, both in positive control and negative control groups, they had to eat almost 2 grams of feed to produce 1 gram of egg. But whereas in enzyme supplemented groups, they had to eat only 1.88 grams of feed. It looks very small, tiny bit of feed here, but when you have 100,000 birds over 1 year production, so that's a heaps of money. So by doing this one, and approximately you can save about $15,000 per year if you have 100,000 birds. The next one is phytate digestibility and fecal phosphorus digestibility. You can see phosphorus digestibility here in positive control diets in both fecal phosphorus and phytate phosphorus digestibility was significantly lower than the negative control diets. The reason here is when you supplement, when some of the nutrients are short supply in the diets, the birds or pigs or chickens, they are more efficient using the nutrients which are in short supply. That's why you will see a better digestibility in case of negative control diet than in case of positive control diet. When you supplement these diets with enzymes, you can see a big improvement in phytate digestibility as well as fecal phosphorus digestibilities. In another study, what we did at the end of the study, these are the different, we were testing 2 different types of enzymes. At the end of the study, we euthanized animals. We collected this tibia sample, this is a bone sample, to measure how strong the bones are. So it's extremely important for pigs, poultry, and broilers. The bones must be very strong. In case of layers, they will be standing or sitting in the cages for over a year. If the bones are not very strong, so that leads to a lot of problems. That's why we will try to make sure the bones are very strong. So what we did, we collect this tibia sample and we put under this machine, this Instron machine, that to measure how much force it requires to break the bones. Okay. The results are here. So you can see the bone breaking strength here. That's measured in newtons per meter square. So this is the control diet. So you can see it needs at least 10 units less to break these bones. So that means these bones are not as strong as bones from these groups because it needs less force to break these bones. And what we did, we took the same bones to check the bone ash, because bone ash also tells you how strong the bones are. If the ash percentage is higher, that means the bones are stronger. You can see here in control diets where calcium and phosphorus is low, the bone ash percentage was significantly lower. When you supplement phytase enzyme, the bone ash percent was significantly higher. So that means higher the bone ash, higher the ash percentage, bones are stronger. The next one is turkeys. In turkeys, we had 6 different diets. So one is the positive control, negative control 1, that's a reduced phosphorus and calcium. In negative control 2, we further reduced calcium and phosphorus levels. And that negative control diets were supplemented with 250, 500, and 1,000 Phytase units. And these are all corn, soybean, meal-based diet. Each diet had 10 replications per diet, 6 birds per replication. And there were 360 60 turkeys, and the total duration was 18 weeks. So the turkeys, they really grow fast. When you look at the average growth rate from 0 to 18 weeks, if you calculate per hour, the growth rate is about 6.6 grams. So every hour, they grow at the rate of 6.6 grams. So what we measured here, from 0 to 18 weeks, this is body weight, and this is the weight gain here. So nutrient levels in diet has got a significant effect on body weight and weight gain as well. If you look at this one is positive control diet, so it's a 16.84, whereas in negative control diet, it's not a big difference between these two. But when you look at this negative control 2 diets, the difference in body weight and both body weight and weight gain was significantly lower. But when you supplement these negative control diets with the different levels of phytase enzyme, you could see a linear improvement both in body weight and weight gain. If you look at the feed intake was also significantly lower in negative control diet, and enzyme supplementation significantly improved weight gain. But the advantage here is that even though feed intake is significantly higher than negative control group, if you look at the feed conversion ratio, there's no significant difference between treatment groups. That's in all the groups, they've eaten more or less same amount of feed to gain 1 kilo body weight. And phosphorus and calcium levels in diets had a significant impact on mortality from 0 to 19 weeks of age. It's about 12.5% mortality we are recorded in negative control diets compared to positive control and negative control 1 diet. The majority of the mortalities here is because of the leg weaknesses. So once they have leg problems, when they are not able to walk properly, then it's very difficult for them to go and reach feed and water. They sit at one place, then eventually they're going to die. So what we did, we supplement these diets with the different levels of phytase enzyme. Then you could see a drop in mortality. So, but however, the mortalities were not significantly reduced, but you can see numerical drop in mortality. The next one is in pigs, in growing pigs. Again, we had 3 different diets: negative control, reduced calcium and phosphorus. Same diet supplemented with either 500 FTU or 1000 FTU. Phytase in corn, soya meal based diets. Each diet had 8 replications, 1 pig per replication, and 24, and total duration was 23 weeks. And what we measured here again is the weight gain and feed conversion ratio. Similar to chickens, you can see negative control diets. The weight gain was reduced, but reduced compared to the 1000 FTU group. But when these diets were supplemented with only 500 FTU, did not make any difference. Both are same. But when negative control diets supplemented with 1000 FTU of phytase, you could see a big jump in weight gain. Okay. Let's see what happened, how much feed they have consumed in control groups and the phytase supplemented groups. This is FCR again. This is grams of feed equate to gram gain. So in negative control groups, these pigs had to eat 1.7 grams, almost 1.7 grams of feed to gain 1 gram body weight. Whereas in phytase supplemented groups, they had to eat only 1.5 to 1.58 grams of feed to gain kg body weight. So, and also we measured ileal phosphorus digestibility, fecal phosphorus digestibility, and bone ash. Yeah, similar to chickens, you can see that phosphorus digestibility is significantly lower in negative control diets compared to the diet supplemented with either 500 FTU or 1000 FTU. Here there is no difference in ileal ileal phosphorus digestibility between these 2 groups. When you look at the fecal phosphorus digestibility, similar to the ileal phosphorus digestibility, here it's significantly lower. When you supplement phytase enzyme, you could see significant improvement in fecal phosphorus digestibility. And also we measured bone ash content to see whether the bones are strong or not when you supplement phytase enzyme. It clearly shows that when you supplement phytase enzyme, the bone ash percentage is significantly higher in these 2 groups compared to negative control group. That means the bones in these 2 groups, the pigs ate this feed had a stronger bones. This is the last one. This is effect of phytase enzymes in pregnant sows. So in this study, we did not study or did not measure any production parameters. It's only digestibility. We had 3 diets, again, positive control, and negative control supplemented with 500 FTUs. And this is a corn soybean meal based diet. Each diet had 10 replications per diet. and 1 sow per replication and 30 sows. The total duration was 3 weeks. So we measured phosphorus digestibility, and you could see phosphorus digestibility in positive control is significantly higher than in the negative control groups. And when you supplement negative control groups with 500 FTU of phytate, so you could see a significant improvement in phosphorus digestibility. Similar to phosphorus digestibility, you can see calcium digestibility in pregnant sows when you supplement negative control diets with 500 FTU of phytase. And also we measured grass energy digestibility. So there was no significant difference between positive control and negative control diets for grass energy digestibility. However, when you supplement negative control diets with the phytase enzyme, you could see a significant jump, significant improvement in grass energy digestibility. Okay, so came to conclusions. In broilers, it improves weight gain, feed conversion ratio, digestibility of grass energy, protein, and phosphorus with a reduced inclusion of inorganic phosphorus. In case of layers, it improves egg production performance, nutrient digestibility, bone breaking strength, and bone ash without supplementation of any inorganic phosphorus in the form of monocalcium phosphate or dicalcium phosphate. In turkeys, improves weight gain, reduces mortality. And in pigs, improves weight gain, FCR, ileal and fecal phosphorus digestibility. And in pregnant sows, it improves calcium, phosphorus, grass energy digestibility. And on top of that, it reduces environmental pollution and creates a safer environment for aquatic life. Thank you very much for your attention. And now I'm happy to take the questions.
Excellent. Thanks very much, Arun. From my point of view, quite interesting from a non-animal professional, but a meat consumer. It's interesting to hear about. I'd invite anybody to register questions in the Q&A. I'd like to start by just asking how extensive is the use of this enzyme throughout the animal industries in Australia?
Oh, okay. See, actually, these enzymes not very old. Actually, the enzyme usage started in the beginning of 90s, 1992, 93. So earlier, people usage is very minimal. But now, mainly, it's like vitamins and minerals in the feed. So everybody uses phytase enzymes, especially in pig and poultry diets. It's very, very common.
Yeah. Okay, and so is it as common? So I take it that it's quite common in the EU, given the ban of some of the other options. Is it as used as favourably in Australia as the EU? Because I take it we don't have the bans yet.
That's right. We don't have. Probably one day it may come. I'm not sure. That's why we should be prepared with a lot of phytase enzymes here.
Yeah. But yeah, so the question was: is it used to the same extent in Australia as
the phytase enzymes? You mean?
Yeah.
Yes. Definitely.
Right. Okay.
So that's the advantage. If you use phytase enzyme, either in some cases we can completely eliminate inorganic phosphorus or meat and bone meal, but in some cases, at least we can partially reduce use of inorganic phosphates.
Yeah. So, and has there been much economic or sort of putting these results in the economic context? So obviously there's benefits.
Definitely, because
benefits. There's obviously a cost, but I guess the assumption is that there is a net economic benefit.
Yeah, see what happens. That's why we always have this positive control and negative control diets, where in negative control diets, we reduce phosphorus, calcium. In some cases, we reduce amino acids as well as grass energy. So if you formulate diets in such a way, definitely the cost of that negative control diets are almost $20 cheaper per ton compared to the positive control diets. And the cost of enzyme could be about anywhere between $8 to $10 per ton. So if you add that enzyme cost and savings, the net saving will be at least $10 per ton with the negative control diets. And that gives exactly the same performance as a positive control diet. On top of that, it reduces the pollution.
Sure. And then, given these benefits, is there exploration in other livestock for use?
So yeah, there are some, yes. Usually in other livestock, they're not using phytases because what happens in other livestock, they produce these enzymes. For example, sheep, beef, cattle, dairy cattle. Because of the fermentation, they can easily produce these enzymes.
Okay.
So they don't need actually.
Okay. Right. Yeah. Okay. Right. Is there any benefit for fish?
Yeah, they do use in fish.
Okay.
Because even fish, they don't produce this phytase enzyme. They do use phytase in fish.
Yeah. Okay. Right. Yeah. Excellent. Thanks. Learn something. Yeah. So I'm not sure anybody else has got any questions at the moment. But certainly, there's been a good run through the work that some of the work you've done and the benefits of that. So that's been really interesting to hear. So first of all, thank you very much for your presentation.
Thank you very much, Craig.
Could you move to the next slide?
Okay, yeah, I will.
Okay, so just like Arun was able to present his work today, we've got another researcher who's presenting his work on the 31st of October. That's Lian Zhao from the Centre of Crop Science. We're not going to have a seminar next week, but I would encourage you all to join us in 2 weeks' time for hearing about the remote sensing applications for Australian cropping systems. So I think that's the last slide, wasn't it, Arun?
Yeah, that's the last one.
Yeah, okay. And then just to advertise that this seminar, or recording of this seminar, along with recordings of other seminars, is available from the webpage. If anybody, I strongly encourage anybody to think about presenting their work. It's a great way to get exposure. And as I've just mentioned, these are recorded and available for future reference to stakeholders within and external to the organisation. And next year, we'll be putting together a new seminar science committee to help with this. So I've got to say that this year they've been very, very helpful in recruiting speakers, and hopefully some of those will continue. But put it in your back pocket. If you've got interest in contributing, I'd greatly welcome it. So I think we'll leave it there, Arun, and thanks a lot for your presentation, and we'll see you again next time.
Okay, thank you very much. Thank you all the attendees.